All right. Well, good afternoon, and welcome. By way of introduction, my name is Sean Bice. I lead a number of the non-relational services in AWS. So over the course of this hour, we'll provide some more updates about what you heard from Andy this morning. So we'll talk a little bit more about Dynamo, Elasticsearch, Elasticache, of course, Neptune. At the very end of the talk, we have pointers to detailed sessions for all these things. So, and then, of course, we'll try to make this fun in a sense of, instead of me standing here for a whole hour, Andy Gutmans will join me to talk about Elasticsearch, Elasticache, and Neptune. Tony Petrosian will join me to talk about Dynamo, and then Joseph Idzarek will join me. He's going to put this really cool demo together, so we're going to put you on the spot today to show, just a live demo of stitching together a bunch of database services. So with that, before we get into that, I get asked a question, or for those of us that have been doing database stuff for a while, 10, 15, 20 years ago, if I was standing here, we'd be talking about relational databases only, and I'd probably be talking about 5 of them. That's it. But the world has changed. And one of the questions I get from folks, business leaders as well as developers is, how do I think about all these different database choices? And, if I were to sort of come up with one word to help people sort of start to reason or think about these different database choices, it's this noun, purpose. And it's really, this notion of purpose or purpose-built is foundational to, many databases that are being built today and tomorrow, but it's really about, from a developer's perspective, picking the right tool for the right job. And what we've learned from history is applications really drive the requirements of what a database should do as opposed to the other way around. And the reality is the characteristics of applications have changed quite a bit. And I'll show you a couple slides here in a minute, just simple framing slides on some of these different characteristics. But the reality is developers today are using relational models. It's been around since the 70s, not going to go away. That's great if you need referential integrity. But developers are also using new data models like key value, time series, graph, and document. And they're using these databases for very specific purposes. What I usually hear from developers is they don't want to trade off scale, performance, or programmability, in the spirit of having like a one-size-fits-all system. It's pretty easy to overburden any database. So let me sort of, I'm going to show you this analogy I share with folks, just to use an analogy to frame up how to think about different databases. So sort of over the page in the lower left corner, a pickup truck is a great utility. I can move dirt with it, I can pull a trailer, I can put passengers in it, and what it does very well. But if we were going to build an airport and we needed to move thousands of tons of dirt, we would go employ an earth mover to do that, because an earth mover's purpose is to move thousands of tons of dirt efficiently. We could elect to use a pickup truck to move thousands of tons of dirt, but we'd probably overburden that pickup truck in a hurry. Now, likewise, if I were going to deliver groceries, like in Amazon Prime, if you think about it, a delivery truck has some really, it looks boxy, but that design and its purpose is very specialized. It's designed to go through city streets, make tight turns, be efficient. That door is open for a reason, so drivers can go in and out. Easy access to put something at a doorstep, get back in, and off they go. We could use a earth mover to deliver groceries, but imagine that thing, wheeling through your neighborhood and the guy jumps out just to give you a gallon of milk. It's kind of ridiculous in that sense. And then finally, if we were going to move cargo, lots of cargo across the country, we'd probably employ an 18-wheeler whose purpose is to move lots of cargo. And in this particular example, these trailers are designed to a very certain specification. So when they back a trailer in and open the doors, there's no adjustment. Handlers literally come right in. They pull all that cargo off and off they go. So this is just one analogy to think about things that actually have a purpose. And if I were standing here today to say, hey, Amazon has one database to do everything, it would sort of be like me maybe saying, there's one vehicle and it's a utility, it's an earth mover, it's a delivery truck, and a cargo all in one. So I don't know that that's really real. Now, let's take a look at app characteristics. So probably one of the more important things that I've learned over the past few years are these next two slides. It really helps me understand sort of different databases that are being designed. So for those of us that have been building apps, pre-cloud era, think back to the 90s. It was pretty common. Eli, this would not be you, by the way. But this would be pretty common you could walk into an enterprise, somebody would build an HR app, a CRM app, whatever. It was usually a single stack. All these applications were typically being built against a relational system. Users were measured in order of hundreds to thousands. Data volume was typically gigabytes. Locality usually was, access was within a headquarters or division. Performance was often measured in seconds. And if you heard about an app that did tens of thousands of requests per second back then, that would be a big deal. Scale was pretty much one way, scale up. The economics where you pay for everything up front and developer access was something, if you were lucky, you could get access to this in a day, but it was often weeks or months. Now, what's changed? This has changed. So the characteristics of cloud applications are very different, and ultimately these app characteristics drive different types of databases. What do I mean by cloud app? Netflix, Tinder, Expedia. These apps can have millions of users in an instant. And you could have 1 million users on hour 1 and 4 million users in hour 3. It can be all over the place. Data volumes can be terabytes to petabytes to exabytes. The interesting thing here is locality now is global. If you heard in the keynote this morning, Expedia is a massively scaled app with globally dispersed users. They literally have users all over the world using that system. Here's a nice one. Performance is measured in milliseconds and microseconds. And for those of us that have built an ad tech app, a microsecond could be the difference between winning and losing a bid. And then scale is up and out and in. It's always easier if you're going to build something to scale it out. It's typically harder to make it go in. A nice thing here, like with Elasticache, Redis, we just announced the ability for cluster resizing such that you can scale a cluster out. And for example, if you're doing a leaderboard, you launched a really popular game like the ones that are coming out now. You had tons of users accessing that game, great. You can scale out a Redis cluster online. Nothing comes offline. And then, of course, as those users eventually get through the surge of the game, you want to be able to scale that back in while keeping the system online. So it's a really cool feature that the Redis team just shipped last week. And then my favorite thing here is really developer access is almost instant. So as a Neptune database comes available, it's a fully managed API. It's instantly available to you. The same thing with Elasticache or Redis. Developers don't sit around. And we often find developers that are building these cloud apps. They're not using one system. They're actually using multiple databases in a single app to actually solve different aspects of it. So over this page, I'm trying to simplify just how to think about the characteristics of these different models. This is the hard part of database stuff. We could pick any one of these topics and be here all day. But I'll just kind of do a quick flyby just to plant some seeds of thought on how to think about this. So if you and I were building an app and we were selling, let's say it was like an Expedia, and we had inventory for seats, well, we would never want to put ourselves in a position where we sold something we didn't have. So in that particular case, we might model our inventory in using a relational model because of the referential integrity, the consistency. That would be a pretty natural and normal thing to do. if we were allowing people to actually shop for flights, and we know flight prices change, the routes don't change, but the prices change pretty consistently. And we wanted to basically ensure, the requirement here was super high throughput, but we wanted to guarantee sort of, single-digit millisecond latency, so that regardless if we had 1 million or 500 or 2 million users, everybody had a consistent experience. We might use key value for that part of the app. And if I were, let's say, for example, I don't know if you've ever shopped for lodging, and typically, at least I remember with my family, we went to Mexico and I hadn't been there in a while. What did I do? I looked at what other people had said about places to stay, talked to my wife about it, and that's how we decided where we went. But wouldn't it be awesome if the next time I was going on a trip like that, if I could see recommendations from my friends from where they stayed? That would be super impactful. And maybe much more engaging, and that's where a graph database could really come in and shine. Now let me show you one example on the left of using a database for its purpose, like graph on the right-hand side, and then trying to use a database to do something that it wasn't naturally designed for on the left-hand side, relational. So if we think about highly connected data, this would be the scenario. So imagine if we built an HR app together. And the question that we wanted to answer was a really high-performing individual, call it top 1-2% talent. This person just abruptly left, and we thought, that's not good. We need to go re-recruit all the people that Jessica Smith worked with. Now, if I were going to ask a question like that of a traditional relational system, the way we might think about that data is, there could be an employees table, departments. Okay, what departments has Jessica Smith worked in? What products has Jessica worked on? What skill sets, etc. And I'd start writing a pretty complex query. I might be joining data across the system. I might say, the people I really want to go re-recruit are top talent like her, so maybe I have to go join some data from an annual review system, and you guys get the picture. It can be complex, and it's a runtime event. On the right-hand side, if I were to model employees with skills, with product, all of these relationships are built right in. And the reality is, when you write a query to traverse all these edges and nodes, you can get back a result set almost instantly. So that's kind of just a very simple way to think about when you use something for its purpose, you get scale, you get performance, and you get full programmability. So with that, let's go ahead and bring, let me just give us a pointer. I'll bring Joseph up here to show us a demo. I'm not going to go through this whole slide. I'll let you guys take pictures of it, but the reality is we've got a pretty awesome portfolio of building blocks. We like to believe every database up there has a purpose, and it's there for you. All these are fully managed APIs. And as you think about building your next generation apps with different characteristics, we want to make sure we have the right building blocks for you. What we're going to do now is focus on the very center, the non-relational databases, and kind of, give you, Joseph's going to come join us here, and, let's go ahead and see what it's like sort of constructing an app and using these different database services to solve different problems within an application. That sound good? All right. Joseph, you ready?
Yep. All right. A few weeks ago, I walked into Sean's office, and he had a picture of a calculator on his monitor. And I had to ask, boss, why are you buying a calculator? This sounds kind of ridiculous. Unfortunately, it was for his teenage son. And then, so Sean and I got to talking about, hey, when's the last time we bought a graphing calculator? And how the world was different then. And we kind of talked about being database guys. We started talking about, hey, how do we create applications back in the day? And I know the last time I bought a graphing calculator was in 1999. I was a sophomore in high school. And at that point, if I was going to create an application then, I would have created a LAMP stack, and I would have put everything in the M, regardless of its shape, form, function, fit, purpose. And I would have made SQL queries work, because that's just what you did. Now, if I fast forward to today, I have a lot more tools at my disposal, as Sean said. So what I want to do is I want to walk through an application that we've built, and we've really taken this calculator, this calculator theme to heart because of the laws of supply and demand have been very good to calculators. Turns out they're the same cost today as they were back when I bought one in 1999, so we figured it'd be a good business to get into. So we've created a demo architecture, and what we're going to show is how to build a purpose-built application using the tools at our disposal. So we're going to use Dynamo for one function, what it's very good at. We're going to use Amazon Neptune, a new graph database, for what it's very good at. And we're also going to use Amazon Elasticsearch Service. So let me switch over. Back on track. So we created a calculator website. And when you start building a website like this, one of the really great experiences, or one of the first experiences you think about is, I want to enable customers to purchase calculators because that's the business that I'm in. So when we think about this experience, we think about a product catalog. We're going to display calculators. We're going to want to have this concept of a shopping cart. We're going to want to be able to process orders, right? We want customers to be able to purchase things, record that in a very durable, available way, so that we can be able to charge them and make money for our business. Now, the database I want to use for this particular set of tables, my products, orders, and shopping cart, is DynamoDB. Why do I want to use that? Well, we heard a really great story about Expedia this morning in Andy's keynote. The other reason is I went around and I looked at, what are the other big e-commerce websites using DynamoDB to power their shopping cart experience, and Amazon is one of them as well. Now, on Prime Day this year in 2017, Dynamo did over 3 trillion requests during that time period and maxed out at over 12.9 million requests per second. So if it's good enough for DynamoDB, I think it's certainly good enough for my fledgling calculator business. The other reason I really like DynamoDB is 2 reasons. It's serverless, so I'm not picking instance types, and it auto-scales. So I don't have to choose how much throughput at the beginning when I'm creating my table. It'll adjust automatically for me as my workload varies. So let me go into the DynamoDB console, and let me create a DynamoDB table. Now, for the purposes of this, I've already pre-created the turkey for our calculator website, but let me show you how this was created. So we'll call this table live product demo. We'll simulate our product ID. And then we're off to the races. Right. So now I have my product. I have my product table, I have my orders table, and I have my users table. Now, if I go back to my website, the next experience I really want to light up for my customers is I want to have a really great search experience. Right? I want customers to be able to find the products that I'm selling, and I want to be able to account for customers perhaps misspelling things, not knowing exactly what they're looking for. I think we can all attest, we've been to websites before, the search experience hasn't been great, and it really sours us, so we want to make sure our customers have a really great user experience. Now, I can build this experience in a number of different databases. I could try to write the SQL to do all this fuzzing logic and handle capitalization and misspellings, or I could use the Amazon Elasticsearch Service, which is purpose-built to do full-text queries. So it enables me to say, like, hey, for the AI series of calculators, I'll just say AI. Perhaps, I heard from a friend that it's AI9 is the calculator to have. And I can use that to do a very intuitive search so I can bring that back for my customers, even if they don't spell it perfectly. Right? So, so now we got my website wired up with Elasticsearch. Now, what we've kind of noticed now is now we have 2 different purpose-built data stores that are powering our website. We have our products table that's sitting in DynamoDB, and now we have this index that's sitting in Elasticsearch. How do we keep these 2 tables in sync and together? Because I don't want customers to be able to search for a product that doesn't exist, and I don't want to have product in my product table in DynamoDB that customers can't search for, because that's going to be a lost business opportunity. So one of the really cool features, and what really enables us to do this, is Lambda and triggers. And DynamoDB has a feature called Streams that makes this very easy. Now, Streams is a feature in DynamoDB that is a change log for all the actions that get performed when I manipulate items on my table. So if I insert an item into my product table, if I update an item into my product table or delete it, it gets written to a queue. and I can use triggers and Lambda to process that data. In this case, I want to add it to my Elasticsearch index. So let me show you how to do that. So first, I want to go into my DynamoDB table that we created. So let me go to the one that we just created. First, I'm going to enable streams, and that's it. Now it's enabled. And the second thing I'm going to do, I've already created a Lambda function ahead of time. So let me just show you that code really quick. And what this code does is when an item is entered into the stream and it hits a trigger, right? We're gonna parse this record. We're gonna say, hey, is this event either an insert or a modify? And we can do the same thing for delete to remove the item from the record. And if it is, right, we're gonna write it to our Elasticsearch index. Right? And then now we don't have to provision any servers to do this. We don't have to have anything that sits there and polls our DynamoDB table to see if there's a diff. This just happens all for us. So let's go back to our DynamoDB table and let's add this as a trigger. Right, so we'll go to triggers. We've already enabled streams, so we're gonna say, hey, I've already written this Lambda function, and I've tested ahead of time, so I'm gonna choose it. And I'm going to choose a batch size of 1. And what a batch size means here is after how many items in this batch are we going to wait till we take action? I want my website to be updated for my customers immediately anytime any record is changed, so I'll create a batch size of 1. Right? So now we have our 2 purpose-built data stores, and now we have a way to keep them in sync without us doing any heavy lifting. Now, so we're doing pretty good now. We have a pretty good business. But as Sean talked about, we have a global customer base that we have to account for now. And we want our data to be distributed across the globe for multiple reasons, but the 2 main ones we see from customers are locality of data to customers. Right? So let's say we're going to expand our calculator business to the UK now. Every time one of my customers from the UK wants to purchase something or go to my website, I don't want them to have to experience the lag of having to go all the way to a DynamoDB table in US West 2 in Oregon, and then having that packet traverse 5,000 miles across the globe to be able to refresh in their browser. I want to have that data in the same region as them. Now, before today, replicating data across multiple regions in DynamoDB took work. But with the recent announcement that Andy Jassy had this morning for DynamoDB, is we now have a feature called Global Tables. And Global Tables is the first fully managed, multi-master, multi-region cloud database. And what this enables us to do, and I was listening very carefully to the words that Andy said in the keynote. He said with a few clicks of the mouse, we can add global tables. And he wasn't kidding. So with this, and I'll show us how to do this, it makes it really easy to create a multi-region, multi-master database. So then we can have writes going into our table in Europe and having them show up in our product catalog in the US and vice versa. We don't have to deal with that synchronization anymore. So we'll go back to our table, and we'll enable global tables. So we'll go down here, and it's literally as simple as saying add region. I'm going to pick Ireland, and I'm going to click continue. And now I've added global region, so Andy was spot on that one. Now, with my calculator business, now I have, because we've expanded to Europe, now I have a product team in Europe, and I want them to be able to procure calculators in Europe. Maybe there's some great calculator technology coming out of Europe, and I want my customers in the United States to be able to purchase those. Right? So let's say that our European team has come across some calculators. And let's insert that data into our global table in Dublin. So we'll call this, let's think of a new name, the Math 4500. That's the name of the calculator. And then the warehouse, we'll call it Westport, a small town in Ireland. And we'll save there. And now let's insert this into our DynamoDB table. Okay, so No, okay. I'm not going back over. So what I want to be able to, so now that we've wired this up, and the entire scenario now looks like this. We have a global table. We just wrote data into our region in US, or in EU West 1, which is the Dublin region. Because we enabled DynamoDB global tables, that item's going to be replicated across to our table that we started with in US West 2 in Oregon. Because we created a trigger with a Lambda function, we enabled DynamoDB streams. The second that item gets written to that table, it's going to be picked up, written to our Elasticsearch index so that our customers can now search on our website. So let's go through that experience and trace that particular item through DynamoDB. So we'll go to our global table in Ireland. Right, and we'll use the table that we already created ahead of time. We'll look at our items. And there we can see on the bottom, the math 4500 calculator is there. So we should expect, if we go to the same table that is now in Oregon, in US West 2, right, we should go down, and now we see, down here we see the math 4500 is there. We'll go to our trigger to make sure everything processed okay, so the last result turned out okay. We'll go back to our calculator store, we'll type in math, and there we can see the math 4500 available for purchase. So there we just created a global application for our customers. With multi-master writes, we enabled both of our teams on both continents to be able to write to this table. Now, one of the experiences we might have glanced over when we first went through this purchase experience together, and Sean touched on this a little bit, is this recommendation engine. And I think it's a very powerful thing now that we kind of actually come to expect with a lot of the e-commerce websites that we go to. But being a data guy, it's always kind of interesting to say, well, how do you actually build a feature like that for a customer? Well, not too long ago, I would have probably made a 17-way join and use recursive CTEs to try to do this in a relational database. And as my data size grows, that query is going to become increasingly slow. But now with the launch of Amazon Neptune, I now have a purpose-built graph database engine to be able to write very intuitive queries to be able to create a recommendation engine. Now, I'm a very visual guy, so I've created a graph of what my social world would have looked like when I last bought my calculator. Now, in the graph world, these circles, these dots are nouns. These are vertexes, and they kind of personify an item. And then the lines that connect the different items are called edges, and they really define the relationship. So the dark blue dots are people, and the relationship between them is no's. So I've ranked my friends by importance to me in that period of my life, and I've given them a weight. We can also see they've bought items such as paper, AV cords, or they've attended classes such as biology and math. And from this graph, we can answer really interesting questions. Now, one of the interesting things about querying a graph database, which is different than relational, key value, or document, is what I'm going to show you is Gremlin, which is a graph traversal language. And what a graph traversal language is, to me, it's a very similar analogy, is very similar to walking through a map. Right? We're going to kind of walk through these vertexes, and then we're going to use these edges to get to different places in the graph, and it provides a much more intuitive experience. Oops. Okay. So I've created a number of queries that I want to ask. And the first one from that social graph that I want to ask is, who are the people that I know? So from this query, I'm going to say, hey, I'm going to start with me. I know I'm vertex 1. And I want to use an edge to say, who do I know? And then what are their names? Right? And now I can see my friends. I have, Vin, Ted is in there, Jess, Allie, Matt, and all my friends back in high school. But I really want to know, when I make a recommendation, I really want those to be recommended based on the people that I like the most or that I think have the most influence on me. So I want to order those now by their weight. Right? And we can get back a similar list. And the last thing I want to do is, not only do I want to know what those people's relationship to me is, but I also want to know what are the items that they've purchased, right? So I can go back in and I can add that to our query, and I can say, hey, now that we've gotten this far, we know, how to query for people that we know by their weight. I can say, hey, for those vertexes, for each of those particular people, I want to know the items they've bought, right? That's the edge. And then for those items, I want to know what the value of the name of that particular product is, right? So I can go back in and I can query. Now, it's not particularly useful for my application because I look everything up on GUIDs. The name isn't useful for me, but I actually want to know what the model is, or the product ID. And that's another property of my items, and now I can return this and I can use this in my website. Okay. So now we have a very powerful graph experience. Now, the last thing we want to do is we want to know what the quality of experience of our website is. Right? We want to make sure we have a really high quality performance. We want to make sure that we know what our customers are doing so we can infer about their actions, as Andy talked about this morning with analytics. Now, one of the really cool features of Elasticsearch, and so one of the really cool things with purpose-built databases is I want to be able to query across a lot of unstructured data, and I could use a lot of different data stores to use this. I've wired up my application to emit Apache web logs. Perhaps every time someone clicks through a particular experience of putting something in their cart, maybe they abandoned it, maybe they did something, they removed it, they added it back. I want to know about that. I want to emit those logs from my data. I want to emit those logs from my application. I want to be able to process that. Now, the purpose-built data store I want to use for that, again, is the Amazon Elasticsearch service. And now, being kind of a visual guy, one of the really cool features I actually like about this particular service is it comes with a Kibana endpoint built into the service. Now, Kibana is a very popular way in Elasticsearch to visualize data. Right? So, once I have kind of my semi-structured data in the Amazon Elasticsearch service, I want to be able to visualize it immediately so that I can start to see what's going on. I can start to create real-time dashboards. And how many people in here are not in an organization that doesn't want to be data-driven and have real-time dashboards? This makes it really easy to do that. Now, my fledgling calculator business hasn't taken off the ground yet, so I've imported a little bit more meaningful data set into Kibana, into my Elasticsearch index to kind of highlight the purpose. Now, from this, I can say, hey, I have, over the last 30 days, I've had over 1 million users, a lot of, unique keyword searches. I can see how many bytes in and byte out are going into my particular website on those days. I can look at the error codes. I can see, when I'm having 300s, 400s, 500s. I can also look at it as total request volume, access patterns to different pages. I can even see where the traffic is coming from. Make a very easy way to visualize some of that semi-structured log data that we get a hold of. Okay. All right. This guy is still blinking red. Can we move over to the other presentation, please? Oh, it's there. Oh, just take a little while. Perfect. Okay, so what we've shown you is a multi-region application. We use DynamoDB global tables to be able to replicate data across the pond to our other region in the United States. We use Lambda to be able to connect our DynamoDB product table with the Amazon Elasticsearch service. And we use Neptune to provide a really powerful recommendation engine. Okay. So let me welcome Tony Petrosian up on stage to discuss or tell you a little bit more about what's new with the DynamoDB service.
All right. Thanks, Joe. That was a great demo, and hopefully most of you saw the DynamoDB elements in there. So I want to just spend a little bit of the time talking about DynamoDB. As you heard, DynamoDB is our key value and document store for high-scale workloads. It gives you a performance in a single millisecond, response time range, regardless of your data size. It's fully managed, so you just create a table and you go. when you have large data sizes with unbounded size, you don't know what it's going to get to, and you need key value and need fast response, DynamoDB is really a great choice of a database for those workloads. And the fact that it's fully managed makes it really easy. And developers have an array of language SDKs to choose from. So if you're writing in Node or Java or whatever language that you choose from, Dynamo works pretty well for you. So we were here last year at reInvent, and we got all kinds of feedback from our customers. And so we took the feedback, went back to our offices and started working on it. And over the last 12 months, we've been doing a lot of work in Dynamo to meet some of the new requirements for our customers. So we've done a lot of work in our adaptive capacity. So as I said, Dynamo is a fully managed database, and so it manages capacity for you all the time. You start using the table, and your throughput goes up. Your application is doing work. DynamoDB can scale up, can scale down to meet the demands of your application. So in June, we introduced this thing called autoscale. Basically, you create a table. Autoscale is on by default, and then you basically set it and forget it. And as the demands of your application goes up, Dynamo scales up. As the demands of the application comes down, Dynamo scales down. So basically, you pay for what you really need with respect of capacity, and you really don't have to spend too much time managing capacity. We also introduced this thing called time to live, which is a TTL, where you can set expiry time for items in the database. So if you have tables that are infinitely growing and you get to a point where you think that you really don't need data from 5 years ago, you can set a TTL, and data will automatically expire in the background for you, so you can shrink your tables and save on your storage costs. Or you can keep the data forever. Your choice. We introduced VPC so that you can include DynamoDB tables in your virtual private networks for better security. And as you may know, Dynamo also integrates with AWS AIM, so you can have fine-grained access control. So now with VPC and fine-grained access control, you get a very good set of capabilities for managing the security of your tables. We also introduced DAX, which is the DynamoDB Accelerator. It's a caching mechanism. It's fully integrated into DynamoDB, and one of the nice things about it is you don't actually have to be fully aware that there is a cache sitting in front of the database, because you basically point your application to DAX, and all the writes go through the cache, and all the reads come from the cache. And with that, you can get microsecond response times because it's an in-memory store for Dynamo. So if you need caching to meet the demands of really high read rates, DAX is really good for that. So that's the stuff that's already been introduced over the last few months. And as you heard, today we announced global tables. And again, this is in response to a lot of our customers who are building applications to interface with their customers. Many of our customers are building application with a global footprint. So as Sean was talking about, somebody like Expedia, I mean, their customers are all over the planet, so where do you serve them from? With global tables, it's really easy. As Joe showed, you can create a table. You can, with a few clicks, you select the regions that you want to replicate to. And of course, this is really important because it's the regions of your choice. So, if you don't want the data to be in a particular region, you just don't choose that region. And you can build applications for if you have this globally dispersed user base where everybody can read and write from where they are. And Dynamo is really, truly the first multi-master and multi-region database, because your writes are done locally. They're not routed to some primary or some master someplace on the globe where then everything gets replicated from. We actually do reads and writes locally, and DynamoDB in the background will take care of all the replication back and forth. You get low latency for reads and writes. And in addition, if you really are the type that needs belts and suspenders for your disaster recovery, now you can globally replicate. So if you want to keep a copy of your data in a different continent for safety and security, you can do that. global tables. Hopefully you will give it a try and give us some feedback with your experience. Now, we also introduced DynamoDB backup and restore. We have on-demand backups now enabled. And the whole idea here is if you need to back up your tables for the purpose of long-term retention, if you need to keep things for 3 years, 5 years, 7 years, 10 years, however long you want to keep them to meet your compliance and regulatory requirements, you can use on-demand backups. Basically, with a single click or a command or an API call, you can issue a backup command, and it's completed in a few seconds, regardless of your table size. This is the first really NoSQL fully automated, fully managed backup and restore system out there. And the fact is, when you click on that button to do the backup, you will not notice that there's a backup running on your table. You don't have to go and provision extra reads because there's a backup running. All of that happens in the background in the backend system. So your application is not impacted by the fact that there's a backup going on. And you don't have to go provision extra resources because there's a backup going on. So you can actually go and click and make backups and keep them for as long as you want. And this is really for a table that may be 200 terabytes and has tens of thousands of partition, and you get a backup with a few seconds, with one click. So we also, and that's available now, and we're also introducing a point-in-time restore. It'll be available in early 2018. With point-in-time restore, if you choose to use it, basically we do the backups continuously for you, and we retain them for 35 days. And with point-in-time restore, it's for those conditions where you're working on something and you accidentally deleted some rows, and you're immediately like, oops, I didn't really mean to do that. So this is our oops recovery system. You'll be able to go back and restore the table to the point before you made a mistake. So let's say you made a mistake at 10 o'clock, you can go to 9:59 and restore the table and get the lost records back. With the on-demand backups and point-in-time restore, I think we cover all of your backup and recovery and protection needs. We're also announcing that we'll be making encryption at rest available soon, and with encryption at rest, all the data which is persisted will be encrypted using your service default KMS keys. You don't have to do any work, you don't have to manage anything, you don't have to change code. And with this, you can meet your compliance requirements and ability to meet some of the regulatory or requirements for having data at rest encrypted. So that's some of the new stuff. Hopefully you will give it a try and give us feedback. And now I'm going to ask Andy Gutman to come up and talk about more exciting things.
Great, thank you. So how many of you are using Elasticsearch? Okay. A lot of Elasticsearch users here? Okay, that's a great crowd. For those who don't know Elasticsearch, it's a distributed search and analytics engine. It's built on Apache Lucene. It's open source. It's very, very popular in the market. You saw an example in Joseph's demo of using Elasticsearch for full text search, but there are a lot of additional use cases people are using Elasticsearch for. First of all, it's very, very popular for application monitoring, both at the infrastructure and application level. We see a lot of use in security event management. IoT is using a lot of Elasticsearch. And then also for clickstream and business analytics, we're seeing Elasticsearch being used very, very commonly. What really distinguishes Elasticsearch is the fact that it's real-time analytics. So as opposed to doing batch analytics and waiting for a few minutes or for a few seconds, you can basically take a huge amount of data, terabytes of data, use Kibana, which is the visualization layer that Joseph showed you, and analyze and drill down into your data basically in real time. So very, very productive. Amazon Elasticsearch Service is our fully managed service for open source Elasticsearch. Really, the key focus areas for us have been to make this super easy to use. Setting up Elasticsearch at scale is hard. It's really not something you want to be doing on your own. We make it easy at the click of the button to set up a pretty complex topology. Could be 3 masters, 47 data instances, and we just do it like that. And if you want it in multi-AZ, we'll do that for you also. In addition, it was really important for us to deliver an open and integrated experience. So we really try and make sure that we expose all the open APIs of Elasticsearch, so you can use all the same tools and applications that you've been using on-premise or in your self-managed Elasticsearch environments. We give you access to Kibana, and so we host Kibana for you. And then we've also tried to really integrate it into the AWS experience. So we've integrated it with IAM, with CloudWatch Logs, with Kinesis Firehose, with IoT, to really give you that kind of AWS embedded experience. Security is a super important aspect of this service. I'll talk a bit more about security in the next slide, but we have a very rich roadmap to make sure that we both help you on security and compliance with this service. And last but not least, Elasticsearch is about analytics at scale. So we're just continuously pushing the envelope of scale with this service, and I'll talk about that in a minute, and then also making sure that it's always available. And today we host that we can host the Elasticsearch in 2 AZs for you. So this year has been a really exciting year for us. In January, we started with the release of Elasticsearch 5. We've actually had 2 additional minor releases of Elasticsearch 5 since then. We try and make sure that we deliver a lot of choice to you as part of this service. So we launched support for C4s, M4s, and R4s earlier this year. We also increased the per node storage to 1.5 terabytes. And in April, we really started to push the envelope on scale, moving from about 30 terabyte max to 150 terabytes and 100 nodes under management. And then a very long requested feature, and I know it took a bit longer than most of you wanted, we launched VPC support in October. And also we exposed slow logs through CloudWatch Logs. So if you have queries that are taking too much time, you can actually see that consolidated. Even if you have 100 nodes, everything gets consolidated in CloudWatch Logs. December is going to be a really big month for Elasticsearch service. We have 3 big releases coming out, and so I'll give you a small preview of those releases. We intend to take another step function in scale. So we'll be launching support for over 1 petabyte per domain in Elasticsearch. We're going to be using i3 instances for that. For those of you who are not familiar with i3 instances, they're pretty much like our R4s, but they have really cool NVMe SSD drives. They give you 3.3 million IOPS, 16 gigabytes per second. Actually, the drives are faster than Elasticsearch, so you'll get about 3 times better performance, but Elasticsearch today can't even push those machines, and so that's going to be coming up pretty soon. We're finally launching encryption at rest, and that's also going to be supporting KMS, so you'll be able to manage your own keys and use that on Elasticsearch. And then Elasticsearch 6, which was just released, I think, 2 to 3 weeks ago, is also planned to launch next month. For those of you who've been on the service for quite some time, you probably saw that in the early days of the service, it took us some time to stay up to date with the recent versions of Elasticsearch. That has really been a key focus area for us. And as you can see, our goal now is really to deliver those within a few weeks. We don't want to deliver new versions too quickly because we have to make sure that they're stable. We put them through security tests, and we really give you hardened binaries. Elasticache, another really awesome service. Elasticache is all about performance and in-memory database. It started as a cache with Memcached, then we added support for Redis. But really, Redis today is being used for a lot of use cases beyond just caching. We see Redis being used for leaderboards, for PubSub. If you want to do any API throttling, usually you'll be using Redis because of its great performance. The latencies you typically get here are in the hundreds of microseconds, so you really get amazing latencies with this service. So, I intentionally call this extreme performance and not performance like we say in most of our AWS sites, because Elasticache is really about taking performance as far as we can. This is a secure and hardened service, very scalable and highly available. We do multi-AZ. We have replication in Redis. So even though it's in memory, we can replicate and we can make sure you have failover across AZs if something goes wrong. So very good, proven, resilient service. The team has had a really awesome roadmap this year. Towards the end of last year, we launched support for Redis Cluster. Redis Cluster is sharding support for Redis. And basically this year, we've added additional features on top of that Redis cluster support. So in March, we added support for backup restore, but this isn't just a simple backup and restore. If you shard in one way, you take a backup, and now you have a whole new topology, and you're sharding in a different way, and you do a restore. We have a smart restore, and we actually reshard the data, and it just works. You don't have to think about it. We added a new version of Memcache. A feature a lot of you asked us for is, how do we know that this multi-AZ actually works? Like, our application is mission critical. We serve a lot of gaming and ad tech with this service. So this is truly a mission critical service for them. So we added a really cool feature where you can actually test failover. You can make the machine fail. We fail over to multi-AZ, and you can actually make sure that, we stay true to our promise on our failover guarantees. Some new features we just released. We released encryption at rest and encryption in transit for Redis. As part of that, we also finally added support for the Redis auth command, which we've been asked for quite some time. Now we've also been able to get HIPAA, the service will basically enable you to get HIPAA certified. And probably the coolest of them all is we now have online cluster resizing. So if you have a peak, for example, if our calculator business, really takes off and we know we have a peak, I know it's Christmas sales, we can basically scale up our cluster. We will resize and reshard that as the peak happens, and it's seamless, so there's no downtime when it happens. But more interesting, after the holidays are over, you want to start saving money. Scaling down is always the problem. So what we've done here is, as long as you have enough memory, the scaling down actually works, and you don't have to worry about it. So you can scale up, you can scale down. Really cool feature. So we talked quite a bit about highly connected data. I think the most important thing here is there's a lot of unlocked value in how data connects. And most data stores today focus on the data versus on the connectivity of the data. So they're critically important, but they're just certain things that are very hard to do. And so if you think about use cases like recommendation engines, like fraud detection, social networking, knowledge graphs, they're just a bunch of really, really interesting use cases. Security, IT topology management and security intrusion. It's all about connections and how people behave or don't behave in the same way. Are people coming in from the same IP address with different logins, taking the same action? Maybe there's some fraud there. The real challenge we've seen, and Andy talked about this in the keynote today, is that most graph applications today are actually built on relational databases. And I'll talk in a second why they're not built on graph databases today. But they've been built on relational databases, and that it doesn't work, it doesn't scale. Graphs usually, they evolve, the schema evolves, and it actually doesn't even have schema in most cases. And going into a rigid schema database like relational database is just too hard. You'd have to change it all the time and create a lot of unnatural foreign keys. Querying graph data in a relational database is too complicated. You end up doing a lot of joins. It's really hard. And if you saw, in the demo, you saw that, we could just query our graph with like one line, and everything is very natural. It's a fluid interface. It's really natural. You're traversing the graph, and you're thinking as a graph. And then last but not least, relational isn't built for graph processing, so it's great at other things, but if you try and run graph queries, most probably your query is actually going to run pretty slow. And so why didn't we go and do, an RDS for some existing graph database that's already out there? We looked at the graph databases, and what we found was, they were either too expensive, they didn't have the enterprise capabilities the customer needed. Graph tends to be mission critical for businesses that are really depending on graph. And we also felt that most graph databases kind of force you into certain graph choice. And we wanted to make sure that we really embrace open APIs, and we give you choice of more than one graph model. And so today in the keynote, in Andy's keynote, we announced the availability of Amazon Neptune. It's a fast, reliable graph database. It's built to store billions of relationships, so really, this thing can scale to a very high level. It is It is engineered for interactive experiences. So you can basically query it with milliseconds latency. We take 6 replicas of your data, so it's extremely durable and reliable. That replica data is in 3 AZs. And so if a full data center or AZ goes out, your graph data is durable and is still running. It's super easy to use. We've intentionally embraced, as I said, open APIs, which means you can find a lot of content out there. You can find examples. And the 2 models we embraced are Apache Tinkerpop, which is part of the Apache Software Foundation. It's an open source framework. And that is a property graph model for those of you who know graph. And the second query language that we embraced is Sparkle, which is part of the W3C semantic web. So that's an open standard. And so anything that supports RDF Sparkle will actually work with Amazon Neptune. So I'll have Sean come back up here. He's going to talk about some of the sessions on non-relational, but I want to thank you for coming.
All right, thanks, Andy. All right. So that's, I'll leave this up here. I think we have 2 slides. Yeah, 2. I'll let you take a picture of these. One thing I wanted to note is Neptune was under embargo. So because it was announced today, you didn't see these Neptune sessions leading up to reInvent. So I'd point out there's Neptune sessions if you're excited about graph, you want to learn more throughout the rest of the week. There's different sessions to go into more details. And the same is true for Dynamo, Elasticache, Elasticsearch, etc. So I'd kind of leave you with this thought. My hunch is that the application characteristics of these cloud applications, in terms of having millions of users and lots of data, things being globally distributed, I think that's here to last. Milliseconds and microseconds is really becoming a new norm. And what I hear from people over and over and over is, most developers are not wanting to trade off scalability, performance, or programmability for the convenience of a one-size-fits-all. And what that really means is when you see something like graph, you're probably going to want to take the full benefit of that programming surface and then enjoy all the scale and perf that comes with it. And I think that's going to hold true for a number of choices that you might make. I know sometimes when you take a step back and you start to think of a certain use case, you might have 2 or 3 choices between a variety of building blocks. I think that's software in general. But kind of going back to the beginning of this talk, the one thing that I've seen hold true and be quite successful is just, I'd always remind you to think about really what is the purpose of a particular database where I don't have to trade off programmability, scale, and performance, and how can it help me solve a particular problem? And odds are you'll end up using a variety of these fully managed APIs to build these new types of apps. And then, so with that, we appreciate everybody's time. I think there's like 25 seconds here, so we actually did make it on time. But if anybody has any questions, come on up and join us up here at the front, and enjoy the rest of your reInvent. Thank you.
I don't think I've ever been that accurate.